Alright, so on to these. We'll go through some of these problems, and we just got to be able to compare these ratios as proportions. So we'll be comparing many fractions that are equal, because we're going to be using the ratios as fractions. But will be important in this whole lesson. We're actually going to be finding equations of proportional relationships. And for the equation, what we're going to want to find is the unit rate. But of course, after the Christmas break, everyone's forgotten about what a unit rate is. A unit rate is where one of the values we're comparing is a Juan. So, specifically for these ones, we want the unit rate, the x value, to be the 1. Okay? Not the Juan value. And we can see, again on this table right here, this column is our x values, and then this column is the y values, because if we look back, not that we remember any of this stuff, but if we made this an ordered pair like these, it's always the x value and then the y value like these. Alright, so let's look at these. Peter's renting wave runners for a company party. Each wave runner holds 3 peoples. Complete the table and graph to show this relationship. Alright, so let's say that they had 0 wave runners, then how many people could they fit on the wave runners? 0. Oh, that's very nice. But if they got one not rave runner. Well, what if they got 1 wave runner? 3 peoples, right? What if they got 2 wave runners? 6. Now, how many people, if they had 9 peoples, how many wave runners would they have? 3, right? That's very nice. And if they had 8 wave runners, now how'd you guys get 24 though? That's the question. Yeah, good. 8 wave runners with 3 people on each, 8 times 3, 24 peoples. But what if we had only wave runners? If we had W wave runners, then how many peoples could we fit?
W.
No.
0.
Now how many people can we fit on each of those?
3.
3 on each of the wave runners. So if we had W wave runners, what would we do to the W?
3 W.
Yeah, you take the 3 times the W, which would be your answer, and that is just an expression. Not that you guys remember what that was because it was like 4 units ago. But it's an expression, 3 times W. Now here's the nice thing about it, these, is now that we know that it's 3 people every wave runner, now if I said, look, I have 12 wave runners, then how many peoples could I put on them? 36. How do we get that? 3 times the number of wave runners, and we can show that work up here, right? We see the number of peoples is 3 times the W, but how many W's does we have? We said we had 12. So I replace that with 12. 3 times 12, bam, 36 peoples. Now that would give us another ordered pair if we wanted it. Not that anyone really wants more math, but we could. That's all I'm saying. So if we had 12 wave runners, it'd be 36 peoples. Now that we have these, and this is good review, because all of these is an ordered pair. So that's 0, 0, 1, 3, 2, 6, 3, 9er, and we could do 12, 36, but we probably won't. This is extremely kind of them because they've labeled the X right down here, number of wave runners. Let me get that up here. And then the Y is the number of people, so we know the difference. Now you guys should be able to figure out the difference if they're not labeled because of your science classes, which talked about independent and dependent variables, which I think we talked about in this class, but I could be wrong. I could have that mixed up with 8th grade. All right, so let's label these points. We got this one right here, and that one was 0, 0. Then we got 1, 3 right here. Label it 1, 3. Then we had 2, 6. Then we had 3, 9er. And then we had 12, 36. That one won't fit. Alright, but we do have these 4 points that we put on right here. And there's our nice, beautiful graph. Alright, complete the table below. So we're just using the same idea. So if I have the expression for number of peoples, we've got 3 wave runners times 3 people each, 9. And we already had that point right here. And then if we had 4 wave runners for 3 people each, 12. And we could put that on the graph right here for 12. And then we got 5 wave runners for 3 people each, 15 peoples. So W would be W times the 3, but we usually write it as 3W, either way. Write an equation that shows the relationship between the number of peoples that can ride and the number of wave runners, W. Okay, so we got the number of peoples. How do we figure out how many peoples can ride the wave runners? Yeah, we can look at the word problem, but it says to write the equation. So this is how the equation works. You guys remember what the number in front of the letter is? It's being multiplied. Remember what we call that? Starts with the C.
Coefficient?
Coefficient, very good. The coefficient is the number we're looking for of W. And specifically, we can look up in here, in this row and this one right here, right? What were we doing to the W to figure out how many peoples? Timesing it by 3. So we just did 3 times the W. This can be found in the table where X is a 1 right here. And then the Y value there, 3, is the coefficient.
What's the coefficient? Is that what you're talking about?
Use your equation to determine the number of peoples that can ride if Peter rents 20 wave runners. Alright, now it says to use the equation. So the equation right now is the peoples is 3 people for every wave runner. Now it says up in here that old Peter, he's going to rent 20 wave runners. Oh. So if we can put 3 people on each of them, then how many peoples?
60 people.
60 peoples. Bam. There we go. Bubba's Body Shop charges $25 per hour to fix a car. We'll complete the table and the graph to represent this situation. So, up in here, we can see that the time, and then we're looking at cost in hours, and it says, old Bubba, he's going to charge $25 per hour to fix some cars up. So, if Bubba works 0 hours, how much is he going to charge you? $0. That's pretty convenient, not only for you, but also for Bubba. Okay. Now, on the other hand, he's going to work for 1 hour, so how much is he going to charge you? $25, because $25 every hour. Well, what if he works for 2 hours? Then how much is he going to charge you? Yep. Bam. $50. But what if he charged someone $75? Then how many hours did he work? That is correct. 3. Well, that's not where that goes. There we go. 3. Well, then he finds on another car that he worked 8 hours. So how would we figure out how much he would charge? Yeah?
25 times 8?
Bam. The 8 times the $25 for every hour. And it costed how much?
200.
$200. Now this next one, we did some of these last time. Not that anyone remembers because of the break. But if he's going to work for T number of hours, how would we figure out how much cost it would be? Yeah?
Multiplying T by 25.
That is correct. So we're going to take T and multiply it by 25. And we could just write it as 25 times T if we wanted to. So that would be the cost. So, for example, if the T were 12 hours, right? 25 times 12 is what we would do. And then we would figure out how much that costs. I think that's $300, but whatever. All right, next up, we got this graph up in here. Now, for the graph, the first thing we need are the labels, which we've gone over already, not that anyone remembers. But we can see up in here in the table that it's already set up as ordered pairs. Now the first value in the ordered pair is the x value, and the second one is the y value. It's alphabetical, starting with x. So that means that our time is the x-axis, and then the cost in dollars is the y-axis up in here. So now that we have those labels, now we need a scale. So the time, if we start with 0, and we want these values on up in here, so we'll just go up by ones. So 1, 2, and so forth. Now this next part we got to be extremely careful because we're going to scale the y-axis. So what should each of the lines represent? And we will start with 0, because we should always start with 0. Unless we're trying to manipulate people's minds, which we'll get into later. But each line up in here, right? Well, we can see up at the top, he's charging $25 every hour. So if we just make this go up by 25 each time, so there's 25. And we got 50, 75, 100, 125, 150, 175, 200, 225, 250. Well, then we got a scale that should work extremely well with the table that we has. So now we can go into these and start labeling our points. So the first one up in here is 0, 0, which would be this point. And yes, we do need to label that 0, 0. That's a 0 right there. Then the next one is 1 hour for 25. So we got 125. And then we got 2 and 50, so 2 and 50, there we go. Then we got 375, that's this next one. So we can see already a pattern in the graph. So it'll go up 25 and then to the right one, $25 for every 1 hour. And then the next one was 8 and 200. Bam, there it is. And it's hard to put t times 25 on that, so we're going to skip that part. Of course, we could draw the line for these if we wanted to. Yeah, none of those really turned out very good. Let's try a different way. That's better. All right. So there's our line on the graph. Well, this next table up in here, it says we want the expression for the cost. So for example, if he works 3 hours, then we got 3 hours times $25 every hour, and we get $75. Of course, we have that in the table right here as well. But we can do 4, which we've kind of already figured out. We could look at the table, or the graph rather, right there. So 4 times is 25 would cost $100. And then finally 5, so 5 times 25, that's going to be $125 for 5 hours of work. Now for T hours, it would be the same idea as we did in the table up above. So we take T, the number of hours worked, times the $25 every hour. And again, we could just write it as 25T, 25 times T. Now let's write an equation for this that models the relationship between the cost Bubba charges to fix your car and the number of hours he works on it. So if we look at the cost, which is C, so we're going to say C is the cost. C is cost. And then T is the time. How do we figure out the cost for this? Well, we can see right here, the cost was 25 times the T, number of hours. So it's 25 times the number of hours. Bam. And that would be the equation that models this situation. Where do we see the unit rate in the equation? That would be, does anyone remember what we call that number in front of the letter, being multiplied by the letter? Starts with C. Yeah? Coefficient, very good. the coefficient, is the unit rate in the equation. Now, where specifically is it in the unit rate or in the table, I guess? In the table, it's seen where x is 1, like it is. In the graph, it's seen where x is 1 as well, like it is. So we should be able to find this coefficient of whatever value we're trying to find in an equation, which we'll look a little bit more over this here in a moment as well. Use your equation to determine how much Bubba would charge if it takes him 12 hours to fix a used car, or your car, what the heck. So we see that the cost is 25 times the number of hours, but the number of hours he's working is 12. So 25 times 12 in my calculator gives me $300. Bam. This next question will involve, I think it was Unit 3, solving equation stuff. Because this one, it says that he charged $175. So the cost is 25 times the time. But in this case specifically, we're saying that the cost was $175. So you guys remember how to solve this? Hopefully a little bit, yeah?
Divide each side by 25.
Correct. Yeah, because what we really want is 1 times the time, 1 hour. Which would have been, so divide by 25. 7, very good. Now it's not just 7 though.
7 hours.
7 hours, very good. How do you think equations are useful? Well, we can just plug in a value and find another value pretty quick with the equations. I'm not going to write that though, because it's a lot of writing. Roberto is recovering from an injury. He increases the number of blocks he walks each day in the following patterns. Draw the figure for day 4 and write the number of blocks Roberto will walk. Well, we can see up in here from the grid that looks like may not have printed very well on yours, but it's 4. So if I start at this point, right here, I'd go over 1, 2, 3, 4, and he's walking in a square pattern. So I just go up 1, 2, 3, 4 up in here, and then he would just walk all the way around the block up in here. Bam! Day 4, nailed it. What is the number of blocks he walked it though? Well, yeah, that's good. He walked 4 here, 4 up in here, 4, and then 4 more, giving him a total of 16 blocks. Well, what if on day 5 he should walk 5 blocks in a square, right? So how many blocks would he have walked it? 20, right? Right, because he would have walked 5 and then 5 and 5 and 5.
28.
What if it was 8?
28. 28.
32, right?
Yeah.
Because he would walk 8 this way, 8, 8, and 8. Bam, 32. What if it was 14?
56.
50, 76?
56.
26? 56. Bam, nailed it. So if he's walking 64 blocks, what day would that be on?
16.
16, that's very good. Any questions? What if he walked 92 blocks?
23.
23? Yes, that is correct. What about on D-Day?
4.
Not June 6th, but 4D. How'd you guys get that?
4 times D. 4 times D.
Yeah, the number of blocks is always 4 times whatever day it is, right? So on day 1, times 4, 4 blocks. Day 3 times 4, 12 blocks, and so forth. Okay. What is the unit rate? Well, we can see one right here in the table. We got 4 blocks for 1 day or per day. So that means we should be able to write an equation up in here. And it shows that D is the day number and the blocks B. And so we got to not confuse that with the 6. So up in here, in this equation we can see that we solved for the number of blocks walked it. And this equals what? Yeah? Well, how do we figure out how many blocks there was for any of them? We did 4 times the day. That was it. Now that is shown also in this one right here on the table, this column. Carmen is making Rice Krispie treats for an upcoming bake sale. Carmen uses 6 cups of crispy rice for 36 jumbo marshmallows. Complete the table and graph to show this relationship. Be sure to label the axes of your graph. All right. Well, what if Carmen uses 0 marshmallows? How many cups of rice, crispy rice, would that be?
0.
0. That's very good. Now again, these are ordered pairs, which will go on the graph. This one specifically, 0 marshmallows, 0 cups of crispy rice, would be right here. Now we're not going to do that for all of them. We'll get to the graph, but let's do the table, all of it first. Now this next one, so this is where we got to be careful, right? This is 6 marshmallows. Before, let's look at this. So we should make a proportion on this, right? So we got marshmallows, and then we've also got crispy rice. Now before, in the words, it said that it takes 36 marshmallows for 6 cups of crispy rice, right? But right here, we want 6 marshmallows, and we got to figure out. I did marshmallow on both of those. Hold on.
Is that 1?
This is crispy rice right here. We got to figure out how many crispy rices on this, right? So how do we get 36 to be 6?
Divide.
We divided it by 6. Yeah, that's good. So we got to divide the 6 by 6 as well. Bam, 1 cup crispy rice. Now some of you guys knew that already, and that's good. But it's important to know how we get it using the proportions. Of course, we'll get the equation eventually too. So if we scale this up now, so if I had 6 marshmallows for 1 cup of crispy rice, then if I wanted to know how many cups of crispy rice for 12, we would simply multiply the 6 by 2 to get 12. So 1 times 2 is 2 cups of crispy rice. Well, what if we had 30 marshmallows? So I'm going to set this up again. 6 marshmallows for 1 crispy rice cup. So what if I had 30 marshmallows? Then how many cups of crispy rice? Well, what do we got to do to 6 to get 30? Yeah?
Wait, 60 to get divided by 2. Wait, 60 to get 30?
6 to get 30.
6,
Yeah.
5.
Yeah, multiply by 5. Very good. So we got to multiply the 1 by 5 as well, and we get 5 cups of crispy rice. So let's try this then. 48 marshmallows. How many cups of crispy rice would that be? Yeah?
8.
Bam. Very good. 8 cups of crispy rice. Now this next one is extremely tricky. Let's look at these. So 6 marshmallows for 1 cup of crispy rice. But what we want is 1 marshmallow. How many cups of crispy rice? Right? So on this, how do we get 6 to be 1? We would have divided it by itself. So we got to do 1 divided by 6 as well, which would just be 1/6. Bam. Now, we got M number of marshmallows. How many cups of crispy rice would it be? Yeah? That's close, right? So we look at that and we think to ourselves, it's 6M, right? Because, well, if we look at this, right, if we had 12 times 6 would be 72, not 2, right there, right? So we got to multiply this by something to get 2, or this by something to get 1. Now some of you guys know, radical. We could just take 6 and divide it by 6 to get 1. 12 divided by 6 is 2. 30 divided by 6 is 5. So we're really just taking the marshmallows and dividing it by 6. So 1/6 m, or you could just say m divide it by 6. That will tell you how many cups of crispy rice you would need. So if I had 12 marshmallows, oh, we did 12 already. What if I had 24, 30, 42? What if I had 42 marshmallows? Well, I'm plugging this in. I could do 1/6 times 42, or 42 divided by 6, which is 7. Right. All right, let's get the graph in this garbage. So we're going to use those ordered pairs in the table. So yeah, even though we did one that had 48 marshmallows, this graph only goes up to 30 marshmallows, so we're not worried about taking this any further than that. So now, if we would make our own scale, we would want it to go up higher, though. Yeah, so that's a really good question. So on at these, for 6 marshmallows, we had 1 cup of crispy rice, so that's a 6-1 radical. And then the next one was 12-2, so that's at these, radical. And then the next one was 35, so that is at these. And 48-8 doesn't fit. 1 and 1/6, I don't know, that'd be about radical. Something like that. And yeah, we could make our line for these. Oh, that's not a line. Let's try these. That's a little bit better. There we go. Alright, so there's our line. And let's do the next table as well. We already have some of the values, but let's show the word. So on at these, first one, we'd have 30 times 1/6, and that is 5. We can put that in the calculator. Of course, it's the same ordered pair radical. The next one, 48 times 1/6, which is 8, right? Which, again, was these. And then m, we'll just take m and divide it by 6, or m times m times 1/6. And that would go over here as well. Write an equation that shows the relationship between the number of marshmallows and the number of crispy rice cups are needed to make Rice Krispie treats. Well, we can see right up in here the number of crispy rice cups, which is R in this case. Just put R. R equals either one of these, so you could put marshmallows divided by 6, or the number of cups of crispy rice is 1/6 times the number of marshmallows. What is the unit rate in this situation? It appears that it is 1/6 cups of crispy rice for 1 marshmallow. That goes right there. The graph shows the cost of bananas based on the number of pounds of bananas purchased. Complete the table to show the relationship between pounds of bananas purchased and the costs. Well, based on this graph up in here, if I purchased 0 pounds of bananas, how much would it cost? 0. That's shown in this point right here. Right? What if I purchased 1 pound of bananas? How much was that cost? Well, there's 1, so we got to be careful on these, right? 1, 2, 3, 4, 5 parts. So that would be 2/5, and since this is in dollars, 2/5 is the same as 40 cents. Or 1 pound, right? So the 1 pound, it appears, costed us 40 cents. Well, we can continue these. If I purchase 2 pounds of bananas, now I'm at this point right here. which is the 4 out of 5 parts, which is the same as 80 cents. Write it down. Okay. Well, we can continue this pattern, right? It's 40 cents for every pound, so if I had 3 pounds, what could we do to solve for the cost? So we don't necessarily right now need to use that graph. Well, how much is it for every 1 pound?
40 cents.
40 cents. So if I take the 3 and multiply it by 40 cents, then I can also get my answer right here, $1.20. So how much would 4 pounds cost?
$1.60.
$1.60, very good. How do we get that? 4 times 40 cents. Bam, $1.60. So how much would B pounds of bananas cost?
40.40.
Yeah, 0.40 times the pounds of bananas. So, complete the equation below to show the relationship between the pounds of bananas purchased and the cost. Well, how much did it cost for every pound?
40 cents.
40 cents. So we'll just put a 40 right here, 40 cents. And then if we multiply it by the B up in here, that would give us our cost. So if I had 10 pounds of bananas, 40 cents times 10 pounds, $4. Bam. All right, let's look at number 6 then. Emerald looks at the previous problem a little differently. He's interested in determining how many pounds of bananas he can purchase based on the number of dollars he have. Complete the table and graph to show the relationship. Assume the bananas cost the same amount as in the previous problem. So, for example, if I had $0, how many pounds of bananas could I purchase? 0. That's a surprise. But if I had $1, how many pounds? Now remember, before it was 40 cents. For 40 cents for every 1 pound, right? Oh, that's not a... There's a pound. 1 pound, right? Well, now what we want to figure out, let's give ourselves some space. What we want to figure out is how many pounds for $1. So how do we do with these? Well, how do we get 40 cents to be a buck? Divide it by itself. Yeah, 40 cents, right? Divide this by 0.4, and then we got 1. So what's 1 divided by 0.4? And you could do that in a calculator. Should be 2.5? 2.5 pounds or 5/2 pounds. That's with $1, right? So for the $1, we know we can buy 2.5 pounds. Bam, nailed it. So if I had $2 rather, how many pounds of bananas could I purchase? 5. How do we get that? Yeah, you doubled it, right? Well, what if I had $3?
7.5.
How do you get 7.5? Yeah, 3 times the 2.5, right? So we would multiply that by 2.05 times 2.5. Well, what if I had $4? 10, right? 4 times 2.5, $2.50. I'm sorry, 2.5 pounds. 10 pounds. So if I wanted to determine the cost, if I had the cost, or the amount of dollars I have, how could I figure out how many pounds I could purchase? Yeah, you're just going to multiply that by 2.5, and you'd get 2.5 times C. Well, that's where they changed it. Complete the equation below to show the relationship between the amount of money Emerald has, D, that should be C right there, and the number of pounds of bananas he can purchase. So how do we figure that out? Well, it shows right here in this one, 2.5 times the cost 2.5 pounds every buck. So if we multiply that by the bucks, then we get how much pounds we can purchase. Compare these two banana problems. How are they similar? How are they different? Well, if we look at these, this is the cost, which was, as a fraction, it was 2/5 times the bananas. Pounds of bananas, right? Now it's the bananas, which is, as a fraction, would be 5/2 times the pounds, times the cost, rather, the dollars. So what changed between these? Well, the coefficient for both of these is just flipped. That's it. Okay. And we may remember that that's just a different unit rate. The rates are reciprocated in this case. So this is the unit rate in this table, and this is the unit rate in this one, and they're just reciprocated, that's all. I guess they wanted us to graph that one as well. Let's graph it! Alright, so we had the point 0, 0 right up in here. 0, 0. Then we had 1 and 2.05, which would be about right here. Then we had 2, 5 up in here. I said 2, 5. Then we had 3 and 7.05. We won't be able to fit too many on this. And then 4, 10. That's all we can fit. Bam. And we'll just connect the points. That's okay. The graph shows the relationship between gallons of gas purchased and cost. Use the graph to complete the table. So they've already labeled the graph and scaled it for us, so we don't need to worry about that. But if I get, we have to use the graph for these though, and that's okay. So specifically on this graph, let's look at some values that we can find. So on this one, we're looking for these grid corners to show a specific value of a point on these. So if we look at this line and we follow it upwards, yeah, that's 0, 0, and that's nice. So we can identify that right now, 0, 0. But as I follow this line upwards, up in here, this doesn't work, nope, still no good. Bam, there we go. That one will work, and we can find the value of this point right here. We can see the x value is 8, and the y value is 30. So it looks like for 8 gallons of gas, you would pay 30 bucks. Okay? And the next value, I mean, if we skip that one, missed it, we can see that 16 gallons would be 60 bucks. And then finally these, 24 gallons for 90 bucks. Alright, so now that we have this, we should be able to figure out the values in the table. Alright, so already we know that 0 gallons of gas is going to cost 0 bucks. But how much would 1 gallon of gas cost? So we need to set this up. I'm going to do cost divided by the gallons. And right up in here, we can see that it's $30 for 8 gallons. Proportion to, so again, we're looking at dollars and gallons, specifically for 1 gallon. And this should be pretty good for us, because then we'll know how much dollars per 1 gallon, which is a good unit rate. So, to get 8 to be a 1, we'd divide it by 8. So we'd take 30 divided by 8 as well. And it was 3.75.
Yeah.
Right? Yeah, good. So, the cost for 1 gallon would be $3.75. Now that should make the rest of this pretty easy, because if I wanted 2 gallons, I would just multiply that by $3.75. And I should get $7.50 on that. You want to check with the calculator, of course. And then we got this next value, 10. 10 gallons of gas, so 10 times the $3.75 for 1 gallon each. And we get $37.50. 20 as well, 20 times the $3.75 for every gallon. And yeah, $75 even. So how do we figure out the cost from the gallons of gas? Well, we can see we were just multiplying all the gallons by $3.75. So we'll just write this as $3.75 times the number of gallons. And that should be our equation for the cost. The cost will equals $3.75 times the number of gallons. Number 8, there are 4 quarts in a gallon. Complete the table and graph to show this relationship. Alright, so we got quarts in gallons, and we got 4 quarts in a gallon. So, let's do this. We can do, it doesn't matter I guess which way we do it. So let's put quarts right here, which would then put it in the X position, quarts, and then over here we got gallons. So that's our Y value now for gallons. And we can see 4 quarts is the same as 1 gallon. So 8 quarts would be 2 gallons. 12 quarts is 3 gallons. 16 quarts, 4 gallons. And then 20 quarts, 5 gallons. Well, we should probably address this. If I had 0 quarts, how many gallons would I have? 0. So that's nice because that gives us this point here at the origin. 0, 0. Alright, so when we look at the quarts on these, well, it looks like we'd want to label these every 4. So there's 4, 8, 12, 16, 20, 24, 28, 32, 36, and so forth. And then the gallons can go up by ones. Now if you reverse these and have the gallons as your X and your quarts as the Y, that's going to be okay as well for now. Later on it will not be okay. Alright? And we'll address that later, but you've addressed it in science as well. So we see this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright. Well, 4 quarts is 1 gallon. And then 8 quarts is 2, 12 is 3, and then it just keeps going up like these. That's the nice thing about the scale is since we determined the scale for the X and Y's, we can make it look like this so that it looks like for every one it's one of another, but it's really 4 quarts for every 1 gallon. So that's why the scale is also very important to pay attention to. Alright, write the equation that shows this. Specifically, it looks like if we found the number of quarts, then we would take the number of gallons. And what would we do to the number of gallons to figure out how many quarts? Yeah, that is excellent. You would multiply it by 4. So what is the unit rate? Well, it kind of told us up here. It's 4 quarts per gallon. There we go.